All right, let's talk about domain and range. So the definition for domain is a set of all possible values of x. So by that, we're looking at how much space something takes up along the x-axis. So for example, here in our circle, we're using all of this space. The range is given all the possible values for x. The range is the values that are created from the domain. So before you can have a range, you have to have a domain. So in this case, our range covers these values. Now, one of the strategies that I really like to use when I'm doing domain and range is this idea that we draw a box around our shape. And it's a little bit difficult for me to do it perfectly, but you'll get the idea. So we're going to draw a box around our shape. Doesn't matter what the shape is. We're going to draw a box, hopefully a better box than this one. And then we're going to pretend for a moment that the shape disappears into the box. So, well, what does that mean? Well, it now means that the rectangular represents all the space that the shape takes up. So what we can do then is we can look for key values that are along the end. So you can see that the box essentially stops here at -5, and it goes all the way here to +5. So the domain of this object goes from -5 to +5. Now let's look at range. The range of this object, how low does it go? Well, it goes down to -5. And how high does it go? It goes up to +5. So that's a quick look at how we can find domain and range of an object. Let's use that same strategy with this graph. It's called a piecewise function because it has two different parts of a graph combined. And again, if we're using the idea of a rectangle, what we can do is carefully outline our shape with a rectangle. Pretend that this shape covers the entire graph. So now all we care about is the endpoints of the rectangle. Then ask ourselves the question, how far left do we go? Well, in this case, -3. How far right do we go? 3. How low do we go? -2. And how high do we go? 4. So that's the domain. The domain goes from -3 to 3, and the range goes to -2 to 4. All right, let's talk about how we write domain and range. Well, we're going to use set notation, and set notation starts off with the curly bracket, which means the set of, and in this case, the set of x for domain, a line that means such that, and then we write in our interval, if it's appropriate. X is greater than or equal to -3, less than or equal to 3, and x is a real number. All right. Well, for range is the same thing. It's a set of all values of y such that y is greater than or equal to -2, less than or equal to, the top is 4, y is also a real number. All right, let's talk about interval notation. So interval notation is a lot less writing, it's a lot simpler to use, and in this case we're using a square bracket. We'll talk about that in a minute. So essentially it's saying the x values go from -3 to 3, which we discovered, and the range goes from -2 to 4. So that's interval notation. There are a few things that we need to fix if the circles are open, and we'll talk about that as we go. All right, let's look at this question here. This is a pretty typical grade 10 question. Gives you a straight line, has a y-intercept of 3, and what we're going to find out is what is the domain and range of this graph. Well, again, if we look at this idea of drawing a box around the object, and then of course the box replaces the object, sort of theoretically, and we can ask ourselves, well, what are the ends? If we notice on the ends here we have these arrows. So those arrows move us in the direction of -infinity if it keeps going on forever in the x direction, and infinity. Well, how low can it go? Again, this arrow goes down forever, so again down to -infinity and infinity. So we have a short form way of saying that. If the domain covers all the values, we say x belongs to the real number system. And same for range in this case, y belongs to the real number system. You may also see sometimes it says reals. I've seen that in some notation as well, and that means the same thing. All right, so let's look at this graph. It's a little bit different, and I want to point out a significant difference here. These have open circles on them. The point of an open circle is saying, well, we're approaching that point, but never quite reaching it. So we're going to change our notation for that. Again, we'll do the same idea. We'll draw the box around this and see where it stops and starts, and then ask ourselves those questions. How far left can we go? Well, -3. How far right can we go? 6. How low can we go? -1. And how high can we go? 5. All right, let's have a look at interval notation. Now notice that the circles were open and I did draw the box around to show sort of the bounds. When we have something that's not equal to, we have to use a round bracket. So in this case, the domain would go as far as -3, but not equal to 3, and as far right as 6, but not equal to 6. Don't confuse this with the coordinate -3, 6. So this is the domain. So the range is going to be from -1 to 5. Again, both round brackets. All right, set notation for this is also different because it's a set of all values x such that x is greater than -3 and less than 6, and x is a real number in this case. Notice there's no equal signs on the inequalities, and the range is y, the set of all values of y, such that y is greater than -1 and less than 5, y belongs to R. Now, you may have heard me mention cheater set notation. Oftentimes, I just will write this on the board. It's a subset of set notation. It's not great notation, but it is what we often use in the classroom or in our notes or in our homework. But if we want to be correct and write the whole proper set notation, this is what it should look like. All right, here's a couple of graphs to have a look at. So I like this graph. It has one open circle and one closed circle, so it gives us a chance to play with domain a little bit. So notice that the domain, we can't really draw a box around it because it is just a line, but the domain goes from 1 to 2 and the range goes to 3. So when we're dealing with writing it in interval notation, because there's an open circle at 1, we can put the domain is 1, 2 with a square bracket, and the range would be y is equal to 3. Now, a lot of people ask me, does the open circle affect the range? And the answer is no, because technically there's at least one point on 3 that is equal to 3, so the open circle doesn't affect the range in that case. All right, let's look at the second graph. Now, hard to tell, but it does look like the left is an open circle and the right is a closed circle, so we're going to go with that. So again, if we look at domain, we can say the domain of this one is round, and it goes from -11, and it goes all the way to 9, and that's a square bracket. Okay, let's look at the range of this function. So if you notice the line, it goes down to 4, and it goes as high as 8. And again, this looks like it has a round dot. So the range would be, square bracket 4 and round bracket 8. All right, let's look at this graph. This is not a linear graph in terms of a line. This is a list of coordinates, so a lot of people don't know what to do. So what I always say is take your points and just drop down and find your x values for each point. And instead of having an interval, you're going to have a list. So the domain is going to say x is equal to, and let's just go back and look at all our points. -1, 0, 1, 2, 3. All right, let's do the same thing for y, except we go in this direction. So we have a 0, we have a 1, we have a 2, we have a 3, and we have a 4. So the range is equal to 0, 1, 2, 3, 4. You don't need intervals. There's no lines connecting these dots. If there was a combination of intervals and line segments, you could have multiple entries for domain or range as appropriate. All right, let's have a look at two special cases. So the first one is a horizontal line. If you think about how far left does it go? Well, it goes to -infinity. And how far right does it go? Well, it goes to infinity. So the domain of a horizontal line is x belongs to R. Let's just say this value here is 5. In this case, y is equal to 5 because it only has one y value because it's a horizontal line. And let's make this one 3. Let's have a look at this graph. This is a vertical line. So if we look at the domain and we ask ourselves, well, what values of x does it take on? In this case, it only takes on one value, so x is equal to 3. However, if we look at range, we ask ourselves, how low does it go? It goes down to minus infinity. It goes up to infinity. So in this case, the range is y belongs to the real number system. All right, let's have a look at this. This is a more complicated graph, and let's look at it in two parts. So essentially, what we have is one rectangle here and a rectangle here. So we can look at these in parts and see what happens as we put them together. So let's look at domain first. Well, I'm going to use interval notation. Maybe I have to use a couple, but that's okay. So it looks like domain goes as far left as minus 4. And let's see what happens in the middle here. Well, a closed circle meets an open circle. So at least one of the points is covered for 3, so 3 is included. So if we were to draw these graphs on the same plane, you would see that they were connected. And so essentially this is domain means that all the points between minus 4 and 5 are covered. This does not mean that that's not got any breaks in the graph. It just means that every single one of those points has been covered. Now let's look at y. Y is a little bit more complicated. So how low does it go? Well, it goes down to minus 2, and then the first piece goes up to 3, but doesn't include 3. And we would also have to include the separate piece here, which goes from 4 to 5, and those are both covered. We could also write two separate interval notations, or we could use the union notation if you're comfortable with that, but I'm okay for now with range being an AND function. All right, let's have a look at domain, and we'll write this in interval notation. So how left can we go? Well, we go to minus 3. How far right do we go? To 3. But let's look at what happens in between. This means that at least one value of minus 2 is covered, so that's okay. Same for 1, same for 0, 1, 2, but not 3. So the domain of the function goes all the way from minus 3 to 3, and I put a round circle here, meaning that 3 isn't included. Let's have a look at the range. Well, the range, again, these are all the values, so we'll just have a look here. And we're just going to write these as a list because none of these are connected. So all we're going to say is y is equal to minus 3, minus 2, minus 1, 0, 1, and 2. All right, let's just review what happens when we have open and closed circles together. So as long as one point is included, if you have an open circle and a closed circle, it's the same as having a closed circle. If two closed circles are stacked, I always say nothing plus nothing is still nothing, so it's still an empty circle. And in this case, that would be all you'd have. And in this case, the last case, you have two closed circles, so two closed circles would give you another closed circle. So what kind of notation would you use? Well, for a closed circle, you always use square brackets. And you can use either greater than or equal to, or, sorry, that was less than or equal to, or greater than or equal to. If you have an open circle, you can only use a round bracket, less than or greater than. If you have a closed circle, again, going back to the beginning, you can use a square bracket, a less than or equal to, or a greater than or equal to.